For every person out there trying to protect our stuff by generating good algorithms, we've got lots of people out there trying to break those algorithms so they can get to our stuff, whatever that stuff might be. So when we're talking about breaking cryptography, we call it cryptanalysis. And cryptanalysis has been around forever, but when we're talking about attacking cryptography, we really have to zero in on certain areas. Now, I got to stress something right now. What I'm describing in this episode are Mike Myers terms, okay? You're not going to see terms like attack the key, which I'll explain in just a minute, on the actual exam. But if you think in these terms, you're going to find a lot of situations that you'll see on the Security Plus make a lot more sense. So let's talk about using cryptanalysis to attack all of our algorithms. So first of all, attacking an algorithm directly, like say AES, is going to be an extremely difficult thing to do. Encryption tools like, for example, AES have been carefully developed. They are publicly understood. There are lots of people constantly trying to crack AES, and thus far we've had no luck. The only way you can attack an algorithm successfully is if you can talk whoever is trying to encrypt you into using something weaker. For example, if I can prevent somebody from using AES and instead have them use RC4 on a wireless network, it's going to make my life a lot easier to be able to crack that particular system. So a new, good, well-understood algorithm is going to be very, very hard to attack. Older algorithms that, because of computing power and maybe understanding, make things a little bit easier to attack. So we rarely attack the algorithm directly. The other way we can attack stuff is by attacking the implementation. Now you've got to be very careful here because for example, if I'm logging into a secure web page, there is an entire process known as Transport Layer Security, or TLS, which uses asymmetric encryption, it uses hashes, it uses symmetric encryption in all these different ways in order to make a secure connection between a web server and a web client. And these different ways we put these things together, which are usually known as crypto systems, is the term we like to use, can often have little weak spots in it that bad guys can figure out and use against us. Probably a great example is the first generation of encrypted wireless networks used an encryption methodology known as WEP. Wireless encryption policy? Here, put it underneath here. Mike Myers is terrible at acronyms, and I always will be. Anyway, the problem with WEP, it used RC4, which is a good streaming encryption, but it was the way they used it caused problems. So, for example, with WEP, the keys were very, very short, which made it easier for bad guys to try to crack it. But worse than that, the different types of keys, if WEP used a secret decoder ring, almost imagine a secret decoder ring that would increment, or A equals 1, then A equals 2, then A equals 3. Bottom line was the implementation of how RC4 was used made it weak. It wasn't RC4 that was a problem, it was the implementation. And interestingly enough, WEP protocol, which is still visible on probably about 5 to 8% of all the wireless networks out there. That was 20 years ago we figured out how to crack that. Why aren't these people upgrading their wireless networks? I don't know. So we can attack the algorithm, we can attack the implementation, but the other place we like to attack is when we attack the key itself. If I can figure out what the key is for whatever you're trying to encrypt or even hash or whatever it might be, then I've got an inside line on you. Now, I got to be very careful here. A lot of times when you hear the word key, everybody instantly says password. That's not exactly accurate. On most systems, you can type in some kind of password and it's transformed into a key. In many systems, they stretch it out because you type in little short passwords and it stretches out, makes it real long. We see those on wireless networks. How they're stored is we add stuff to it called salts and things like that, which we'll see in other episodes. But that's where most of the time you'll hear things like, for example, brute force attack and things like that. And again, we'll do all that in a separate episode. So when you're thinking about cryptographic attacks, when you're thinking about being a cryptanalysis and you're going to break stuff, remember there's three big venues: Attack the algorithm, attack the implementation, and attack the key.